before I do the demo, I would like to introduce this EED set. This is external ventricular drainage system. So this is the intraventricular catheter to inserted through the vein and through the lateral ventricle, drain out the CSF. So indication for the EED system is for the patient with the head trauma, hydrocephalus, cerebral edema, and then the intraocular hemorrhage. So, okay. Now we go to the monitor. As you can see, this is the normal waveform of the ICT. It contains three waveforms, P1, P2, and then P3. The highest one is P1. So second one is P2, P3. So P2 cannot be more higher than P1. If P2 higher than P1, that means the intracranial hypertension. So the highest point should be P1. So this is the correct waveform of the ICP. The ICP level reading should be 5 to 15 millimeter mercury. If ICP 20 to 30 means there is a mild intracranial hypertension. So this EED set actually has a scale in millimeter mercury. After we adjust this scale according to the ICP reading. That's all for the introduction of this EED system. Today I would like to show you how to do zeroing of the EED and then how to measure the ICP. So before that we need to know this system. This is the external ventricular drainage system. So it consists of the ventricular catheter, then this EED system, and then this cable connect to the monitor to measure the ICP. So indication for this EED system actually is to measure the ICP and then to facilitate drainage of the CSF. Yeah, this one is CSF free. So complication is the infection or blockage of the intraventricular catheter, and then the excessive drainage, which can cause ventricular collapse. So first of all, before we do procedure, we need to prepare a trolley. This trolley consists of this hand sanitizer, and then alcohol swab, and then the catheter lever. So first of all, usually we need to inform the patient. So madam, today I would like to measure the zeroing and then measure the ICP for you, even though patient is unconscious. So, okay, use a hand rub to do the hand rub. Now we need to position the patient. Make sure the head is neutral. Okay, and then the head up 30 degrees. So, Anita, why do you need to put patient head up 30 degrees?
To promote the venous drainage and also to enhance respiratory.
Yeah, to promote venous drainage to prevent the cerebral edema. Okay. So, first of all, to measure, this is the tragus of the ear. Let me show this EED system. This stopcock is the same level as the tragus. And ensure the bubble is in the middle. So Lisa, do you know why we need to this one measure from the tragus of the patient's ear?
Vestibular reference.
Yeah, this is a ventricular reference point for the brain. So after that, make sure the same line. Okay. Now we need to do the zeroing for the patient, for the this EED. So close this system. So this is the EED system. First of all, this thing is atmosphere, this one is patient. So close to patient, open to atmosphere. So this one is open. So we press some water out from here. After that we go to the monitor, press the zeroing. The zero the ICP. So wait until it becomes 0. Okay. The time is indicated here. So zeroing done. So go back to main screen. So now we need to put back this one. So we must use the alcohol swab to swab it at the opening to prevent any infection. So after swab it, okay. This one indicates patient and then this one is atmosphere. So we close to atmosphere, open to the patient. Then this tubing is actually connected to the drainage system like that. So this one is a drainage. So close to drainage, open to the monitoring. This one also open to the patient. So now we go back to the monitor again. So press on the optimum scale. Okay. Another one more time. So this is the correct waveform of the ICP. So it's around 13 to 14 and then to 15. Okay. This is the whole procedure of the zeroing and then ICP monitoring. So do you understand what I think?
Yes.
Okay. So can you do a little demo for this station? Now you're doing a demo.
And then information. Madam, I want to do zeroing for the APD drainage empty. And then put patient on 30 degree. Okay. And then after that, prepare the tin. It's another again. We need the alcohol swab and also cutting thermometer. First, we need to measure at the triangle of the ear to the off and to the off to the stop clock one. And then make sure all the bubble at the computer ruler at the middle. Okay. After that, close to the patient and then open to atmosphere. Then press some water out. And then after that, go to monitor, press zeroing, zero ICP. So until the ICP is 0. Then after that, back main screen. Then take alcohol swab. Find the both opening before close to prevent infection. Then after that, close to atmosphere. And then this one make sure to off, on, open to patient, and then close to drainage. And then after that, go back to monitor and press optimum scale. And then this one is the correct ICP wave. So it's a 11.
So yeah, well done. Yeah. This is the correct procedure. Do you have any question to ask me regarding this?
When to do the zeroing, huh?
Actually, anytime when we do turning for patient, to position the patient, we need to do zeroing. Second time is when we took over from patient, when changing over shift, we need to do the zeroing.
Why we need to do zeroing?
So zeroing is to make sure the ICP is correct, the reading is correct. Yeah. Okay, if you didn't do the zeroing, the reading will be wrong, about 2 mHg. Yeah. To make sure that the reading is correct.
So what actually we need to monitor from here? The abnormalities?
Yeah, this is the CSF from the brain. So we need to monitor if any blood stain, heavy blood stain from here indicate there's a hemorrhage. So we need to inform the doctor, or any cloudy color changes. If it's cloudy, then we need to inform doctor. Maybe there's an indicate infection is going on.
Oh, how much is the drainage? We need to inform the doctor.
So actually for normal human, it's ICP CSF production is 20 to 30 mils per hour. Every shift, let's say 7 hours, is more than 200 mils per shift. We need to inform the doctor.
Okay.
So, okay, any other question you don't understand?
So far now, I understand.
So far, understand.
Yeah.
So the complication is, let's say when we need to put out the patient, let's say it's a conscious patient, when we need to put out the patient high, so we need to close the initial is closed when patient put out high for conscious patient to avoid excessive drainage of the CSF. So it will cause a ventricular collapse and cause the subdural hematoma.
Okay.
Then second thing is the infection. Every time you do zeroing, we need to hand swab and then use the alcohol swab to swab the opening. Okay.
Okay.
Understand?
I can understand.
I think that's all. Okay. Thank you for the demo. Okay, thanks. Anita, do you have any answer, any question to ask me regarding this EEG system?
I want to ask why we need to do zeroing for the patient, huh?
When we need to do zeroing, yeah, we need to do zeroing every time we position the patient. After we do back turning, we need to do zeroing. And every time we go over from one shift to another shift, we need to do zeroing. Yeah.
Why, yeah?
Because it's a ventricular reference point to make sure that the ICP reading is correct. Yeah, not out of the range. Yeah. That's why we need to do zeroing.
Okay. What is the abnormalities of the...
Okay, any things to observe? Yeah, we see this chamber. We need to observe the consistency of this CSF. So whether it's a heavily blood stain or any cloudy color. If cloudy means infection, we need to inform the doctor. If hemorrhage means also there's some bleeding, so we need to inform doctor immediately. So any other query?
How much is the fluid in the chamber to inform the doctor?
So every time our CSF production is 20 to 30 mils per hour. So one shift, let's say 7 hours, is more than 200 mils per hour per shift. So we need to inform the doctor. Yeah.
Okay.
So regarding the complication, if we drain out, every time we must make sure when we put up the patient, we need to close the AVP. So excessive drainage can cause the ventricular collapse. Yeah. For this, so every time we do zeroing, we need to hand out and then swab with the alcohol swab to prevent any infection. Okay, do you understand?
I understand.
Okay, any other question?
So far, I don't know more.
Okay. Thanks for the demo.
Okay.
Thank you.